Hello friends, welcome in this video. Most of the tasks we deal with the microcontroller are not in the real time, but sometimes the real time response becomes very important, like reading a button press or responding to a sensor value, and so many other things. But without the use of interrupts, it is not possible. So in this video, I am going to tell you that how interrupt actually works and what are the various modes in which the interrupts can be triggered. So first of all, let us understand what are interrupts. So you can understand interrupts like suppose you are studying in your room and someone knocks on your door. So what will you do in this case? You will open the door and handle that person. After handling that person, you again start your study. So same type of process also occurs in case of microcontroller. Suppose an external event is triggered by some external source or the internal source, right? So these are some of the steps of interrupt handling. So these five steps are steps for the normal execution of the program, right? And suppose after step number 3, the interrupt is triggered. So the microcontroller will move on to the ISR, right, which is called interrupt service routine. So whatever the logic you decide for the interrupt, that is written inside in this interrupt service routine, right? So after step number 3, the microcontroller stops the normal execution and then move on to the interrupt handling, like this interrupt service routine. So after performing the step number 1 and step number 2 of the ISR, the microcontroller then again returns to the step number 4 and step number 5. That means the normal execution. So in this way, the microcontroller handles the external event or the internal event, which is written inside the interrupt or the interrupt service routine. Right. So here I have written some of the definitions of various kinds of interrupts. You can read from here. Quickly, let me give you the summary of all kinds of interrupts. So hardware interrupts are triggered by the external hardware devices like keyboard press, mouse clicks, timer overflow, right? And about the maskable interrupts, so these can be turned, enabled or disabled by the program. And these can be ignored or the masked. That is why they are called maskable because these can be ignored temporarily by the microcontroller. Okay. And if we talk about the non-maskable, then they cannot be disabled or ignored by the microcontroller because these are used for very critical events inside the microcontroller. Right? Suppose power failure detection, memory error, or watchdog timer expiry. And external interrupts are triggered by the external devices connected to the microcontroller, like push button, sensor, or some other peripheral. And internal interrupts are generated within the microcontroller. No external source is involved in it, like division by zero error, invalid opcode, arithmetic overflow, right? And software interrupts are triggered by the software instruction or the program which we upload in the microcontroller. No external hardware is required for this, right? So in this video, we are going to discuss about the hardware interrupts. So now let us quickly move on to the demonstration of the. So this is a program without using the interrupts. So I will give you two demonstrations, one with the interrupts and one without the interrupts. So in this program, I am using red LED and the green LED and one push button which is connected to pin number 2. And in the setup function, I am defining the mode of the button as input pull up. So there are two modes, input and input pull up. So what happens in the input pull up? The pin remains in high when it is idle. That means if you are not pressing the button or not releasing it, the pin, that means pin number 2 remains in high position. So what happens, the internal pull-up register in the microcontroller keeps it at plus 5 volt. Okay. So there is a register called internal pull-up register which keeps the pin number 2 in high position, right? If you are using internal pull-up, that is why it is called pull-up. That means uh, defining the voltage at pin number 2 at plus 5 volt. And in the loop function, I am reading the digital value of the button, right? And storing in the variable button state. And if the button state is low, I am writing the high voltage on the LED, that means red LED, and otherwise the low voltage. And in this part of the code, I am using the green LED as usual. Okay. First I am writing high signal, then after delay of 1 second, I am again writing the low signal. Okay. So let us try to upload this code in our Arduino Uno and let's see what happens. So the code has been uploaded. Let us see the demonstration of the program without using interrupts. So this is the demonstration of the program without using interrupts. Let's see what happens if I try to push the button. So you can see I pressed the button but the LED is not blue. After pressing again, the LED is on. If I again press the button, the LED should be off
but it is not off, right? If I again press the button, you can see the LED is in on state still. Okay, after some time it is off condition. So this is a random behavior the LED is showing to us. This is because we are not using interrupts in the program, right? So let us try to demonstrate this same code using interrupts.
This is a program which is demonstrating that how interrupts works. Everything is same as the previous program, except that I'm using the attach interrupt function to trigger the interrupt. And you can notice that in this program, nowhere else I'm using the button state. Instead, I'm using the mode of the interrupt to read from, like rising, change, or falling. Okay, nowhere else I'm using the button state in this code, because there is a common issue with the mechanical button that whenever we press the mechanical button like a push button, the metal contacts inside it touch when we press it. Okay, and pressing it once should produce only one change, either from low to high or high to low. But in real life, when the contact touch each other, they debounce several times. Okay, so code understand that the button has been pressed or released several times, so it triggers the interrupt multiple times. So to prevent that, we are using the mode of the function instead of reading the button state. So let us understand the syntax of this line. So attach interrupt is a function which is used to trigger the interrupt, and digital pin to interrupt is a function which attach the interrupt on a specific pin. So we are attaching the interrupt on the button pin, okay, pin number 2. And toggle is an ISR, that means interrupt service routine, which will be called automatically whenever that interrupt is triggered. So here I have written the toggle function, okay. And rising, change, and falling are the three modes of the interrupt. So what happens in the rising mode? The pin goes from low to high. Okay, that is why it is called rising, because the signal is changing from low position to high position. And this happens when we release the button, right? And in change, what happens? Whenever the signal goes from low to high or high to low, in both cases, the interrupt is triggered, right? And in case of falling, the signal goes from high to low. And it happens when we press the button. And note that these three modes happen. That means release the button in case of rising, press button in case of falling happens only when we are using input pull up, right? If we are using simple input, that means this kind of mode input, then the uh, process gets totally opposite. That means in case of rising, it will happen when we press the button, and falling will happen when we release the button, right? So that is the difference between input. Now let us try to upload the code in the microcontroller, and let's see what will be the demonstration. So let us upload the code.
So this is the demonstration of interrupts using the rising mode. You can see I will press the button. After releasing it, the LED will toggle, right? If I press, the LED will not toggle. After releasing it, it will toggle. Okay, you can see here. So after releasing, the LED is toggling, not on pressing, right? Now let us see what happens in the changing mode. So this is a demonstration using the change mode. So in this mode, the LED will toggle on both pressing and releasing, right? You can see here I have pressed and released. In both modes, the LED is toggling, right? On pressing it is glowing, and on releasing it is not glowing. Now let us move on to the falling mode. So this is the demonstration using the falling mode. In this case, the LED will toggle only when I press the push button, right? As you can see, I pressed a button, the LED is toggling, right? So this is about the falling mode. So that's all for this video. If you have any doubt regarding the interrupt and its various mode, you can comment down below. So we will meet in another video with the new topic. Till then, thank you.